Okay, good evening. So, automobile engines and components. This is our third discussion class. So, here we will be start discussing about the automotive engine. So, I hope you got what we discussed. We didn't discuss anything hard or anything difficult so far. And today also we are going through some very simple sections. We actually don't have any like very complex sections. This is more hands-on approach module. So, until we can actually go ahead and start these practical sessions, we will be discussing in a similar pattern like this, but it will be more beneficial rather than just standing and assembling or disassembling things. So we'll be discussing like step by step how to approach this. That's the plan here. So yeah, so we'll go ahead and start. I think you can remember first day we discussed about the safety, second day we discussed about the equipments and workshop tools, that sort of things. And I hope you have a very good idea and you might have read about that again a few times. So you might have gone through the links I have sent. So I expect you have done these things because from here onwards, these things should be necessary. And I expect to ask a few questions on that. And yeah, next class, at the end of the next class, I'm expecting to have small quiz based on what you have learned so far and what you will be learning on that particular day. Okay, so we'll go ahead and start. So we will be moving to the next section of our module. So that's is related to automobile engines, automotive engines. So here we are going to discuss about the engines, what sort of so there's no point of actually discussing about what sort of engines we have because you have already learned these things in your foundation in automobile technology module. So here what we're going to discuss is how to assemble, how to disassemble, and how to inspect an engine and just to get a brief idea about the components, the construction, why these things are constructed in such a way, that sort of things. So you have to understand this module is very important for you guys, mainly because yeah, mainly because of this module will be used. This module will be actually coming up again and again. What you learn here in this module will be coming up and again. In your other module, for example, if you are learning about thermodynamics, then you are discussing about the cooling system. And when you are talking about the auxiliary system, you are discussing about the air conditioning. So how this air conditioning system is integrated into the engine, that sort of things you need to know, right? So for those things only we will be actually dismantling a whole vehicle and understanding these things. Okay, so we go ahead. So what will be discussing? So basically we will be discussing about removing an engine from the vehicle, inspecting an engine, dismantling, and parameter testing. So in this parameter testing, we are going to discuss about the coolant pressure, engine compression testing, injector testing and calibration, and engine overhauling and reassembling of engine. So basically everything related to engine we are expecting to discuss here. Okay, so first thing, as usual, safety is the first one. So you always have to follow the workshop regulation. That's a must, and you have to wear the protective gear and everything before you approach any vehicle or anything to do with the practicals. And in addition to that, you have to always be aware about the work others working around you. Since when you are doing practical, you will not be the only person around there, so you will be doing it as a group. So you always have to keep that in mind, because sometimes you may actually hit someone with a tool, or components may drop on someone's leg. So you have to be very aware about your surroundings, right? So that's one thing you need to remember all the time. Okay, so we'll move into the engines. So first part is removing the engine. So removing an engine, you need to removing an engine, you might think like it's very simple. Of course it's very simple, but in order to remove an engine, you need to know the correct procedure. correct procedure, right? So that's what actually going to discuss here. So removing the engine, step one. So I'm going to discuss in 10, 11 steps. What are the steps you have to follow, and when you are following these things, what are the other things that you have learned previously, which will be involved in here. For example, we start from step one. So step one is actually inspecting the engine and find out the drivetrain layout of a vehicle. So this is one important aspect of any engine. So of course, when someone asks you to remove the engine, first thing you will open and see, okay, this type of an engine, right? So by looking at an engine, you should be able to understand what sort of an engine is this, what sort of inputs, outputs are coming from this engine. So based on that only, you need to actually act. So here, that input outputs part, what are things involved in this engine? Those things you learned in the foundation in automobile technology and your A levels, right? So those knowledge you gain earlier will be directly involved here, right? You have to directly apply it. Okay, so first one is drivetrain layouts. So there are few drivetrains. There are more than three drivetrains. So there are three drivetrains shown here, but there are more than three drivetrains. But I'm only going to discuss at the moment only the most common drivetrain. So most common drivetrains are the rear wheel, front engine rear wheel drive, and the other one is front engine front wheel drive, and the other one is front wheel four wheel drive. So those are the four most common engine drivetrain layouts. There are other drivetrain layouts, for example, rear engine rear wheel drive, mid engine rear wheel drive, mid front engine front mid engine rear wheel drive, front engine all wheel drive. So there are so many other uh, layouts, but we will just stick into about these three for now, just for study purpose, for make it easy. Otherwise we have to go through each one by one. The time, limited time we have, we can't actually go through everything, but you get the basic idea from this. Okay, so first thing you need to understand, as I said you before, understanding what is the drivetrain layout. So by understanding the drivetrain layout, you can actually identify what are the major components and how they are actually arranged in the engine bay, right? Then in order to remove the engine, you know what are the components you actually have to remove. For example, if you want to remove the front engine, right? If you want to remove a front engine assembly, so then assume that you have to remove the front engine as well as gearbox. So engine and gearbox as a whole assembly. If you want to remove both outside, then what you need to do is remove the drive shafts. One of the main things you have to remove is drive shaft, because drive shaft are the power is actually sent to outside from drive shaft. If it is a rear wheel drive, then you only have to remove the propeller shaft. But if it is a front four wheel drive engine, so then you have two propeller shaft available. So you have to remove both of these. So these sort of information you need to gather first. And in addition to that, yeah, by looking at an engine, you should be actually able to understand how the engine mounts are actually organized, or where are they located. For example, what sort of a engine mount arrangement is available for a front engine rear wheel drive, and what sort of a engine mounts arrangement is available for the front engine front wheel drive. Okay, so we will discuss about this engine layout, engine mounts thing later on, but by looking at this you can understand that. In addition to that, right, in addition to that, there are few other things you need to actually notice. So by looking at this, you need to understand, okay, what sort of a vehicle is this? For example, it could be a old vehicle or a new vehicle, or it could be a European made vehicle or a Japanese made vehicle. So by looking at the engine and the vehicle, you should be able to understand what sort of a engine and what sort of tools you actually need. And the last thing you should able to understand is, by looking at the engine bay, you should be able to understand how easy it is to take the engine out from the top, or whether is it easy to take the engine out from the bottom. So there are two ways to take the engine out. There are actually basically two ways. There are a few other ways which one more way that we can use, we will discuss in the latter part of this discussion. So basically you can either take it from the top or you can take it from the bottom of the vehicle. So if it is taking out from the bottom, there's the components you have to dismantle or disassemble is different. But if you are taking it from the top, then the components you have to disassemble is different. So based on these requirements, the tools and equipment you need is actually different. So you need to understand this. So by looking at this vehicle, you can understand. In addition to that, you should be able to understand what sort of a fuel system is available. So there are two fuel systems available for any vehicle. So that means either it's a carbureted fuel, carbureted vehicle, or an electronic fuel injection vehicle, or a manual fuel injected vehicle. Whatever it is, there are two types of fuel systems available. One is non-return type fuel system, other one is return type fuel system. That means the fuel tank, the fuel coming from the fuel tank come up to the, for example, if we take the carburetor, the fuel pump is, assume that fuel pump is located inside the engine bay, then fuel will be coming up to the fuel pump, then it will be actually delivered from the fuel pump, it will be delivered up to the carburetor, right? But when the carburetor uh, float chamber is completely filled, the fuel pump will not be actually delivering any fuel back to the fuel pump, the carburetor. Instead of fuel will be returned back. So that sort of a arrangement we call it as a return type fuel, return type fuel system. And in modern, most new vehicles actually have something called non-return type fuel uh, system. So in
Sir,
those,
excuse me. Are you moving slides?
no, 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 I'm not moving right.
Okay, sir.
Yeah, okay. Yeah, from next day on, I will put numbers on the slide so you will be able to understand if I'm moving. Okay, so I'm still discussing about this layout thing, right? So in addition to this, yes. So the other one is electronic fuel injection system or modern vehicle. They have returnless type. So where you have a fuel pump at the back of the engine, back of the vehicle or inside the fuel tank. So it will actually deliver fuel through one line, but return and everything, pressure control and everything is actually done uh, inside the fuel tank. So it's not actually having a return. So you need to notify these things. And in addition to that, the electronic, if it is an electronic uh, fuel injection system engine, so then you have PCM or power system, powertrain control module, right? Powertrain control module, also known as ECU. So ECU and powertrain control module is actually different. I hope you know the difference. If you just don't know, just put me a text. I will explain that also. So for example, for these things, the powertrain control module for European vehicles, most vehicles actually from like 10-15 years ago also they started putting the powertrain control module or PCM in the engine bay. But in the other like Japanese vehicles, like very recently only they put the PCM in the engine bay. Previously they used to put the engine PCM inside the driver cabin, or we call it cockpit, inside the passenger compartment. So when these you have to actually identify, okay, these people, these components are here, so I need to disconnect these things in such a way. Okay, so that's why first you have to actually inspect the drivetrain layout and all the components, how everything is arranged. That's what. So first thing is understanding that. Okay, so that's your first step. First step is actually gathering more information. So once you actually gathered like everything, then first thing is you can actually remove all the major power train components, like power transmission component. So that includes the drive shafts or propeller shaft. So you remove everything. Here I am actually discussing about taking the engine with the gearbox to go engine and gearbox complete assembly out from the vehicle, right? Not a single component, both have to be taken out. That's what we are going to discuss here. So Yeah, first thing, inspecting everything and identify where every component is going, and finally disassembling all the powertrain or power transmitting components that are connected to the engine gearbox assembly. That's the first step. Okay, we'll move to the next step now. Second step is collect the necessary tools and equipment. So yeah, so as I told you earlier, first you need to identify what type of engine, what are the components, tools, or what are the equipment and tools you need. Okay, so last week we actually discussed about the tools and equipment, so I'm guessing you have a pretty good idea what are the tools and equipment you need, right? So I have a question. Alutotta,
Yes, sir.
so can you just tell me what are the general tools and equipment you need for engine removal? General rules from the last week.
General tools.
Yeah,
We
Alutotta.
want to lift.
Okay.
Then the parts names I forgot, sir.
So you only need a lift.
No, sir. I forgot the names of the parts.
So do you need a complete toolbox?
Yes, sir.
You need the wrenches.
Ranges and they have some.
Sockets. Okay. So yes, we do need a. Thank you, Altata. But the answer is not complete. Of course, we need the what you call this lift. But lift is not the first thing you need. The lift is like the last thing you need. First thing you need, these are tools. So let's say in case if you have to answer any question like this, first you can't actually solve. This is actually a general question, so it's asking general tools and equipment. So your answer should be toolbox, a complete toolbox. That's why I actually put the complete tool cabinet here. So you need to have a complete toolbox. So complete toolbox means everything is there, all the general tools are there. With all the general tools, usually you can actually tackle a job like this. So you need that, and you especially need the engine crank, or we call it as the engine load lever. So we need the engine load lever, and in addition to that, any other things like supporting or jacks or something. Sometimes we actually need these things in case the space underneath the vehicle may not be enough. If the engine is, for example, if it is a inline engine gearbox assembly, some cases if it is a car, mostly for cars this is actually happening when the gearbox is longer. Engine and gearbox assembly, if it is longer actually, then it's very difficult to tilt because the gearbox started to hit on the, it started to rub against the floor. You can't turn more than that. In such cases, you actually need to lift the vehicle even a little bit, few inches from the ground in order to get the necessary clearance. So for get that necessary support, you need to actually have a jack, so jack stands or even a lift. Okay. So yes, so you should be actually able to answer this question. So what are general tools needs? You need to actually answer. Okay, these things we need. If this is the scenario, we need something like this. If this is the scenario, we need something like this. That's how you answer this sort of a question. Okay, so you gather the necessary tools and equipment. I'm not going to go through all the tools and equipment because we already discussed this part next week. Yeah. So step 3. Before start working, right, before doing any works, first thing is you need to actually disconnect the battery, right? First thing is you need to actually disconnect the battery. So disconnecting the battery is one of the most important things here, because any works, before you do any works inside the engine bay, first thing you need to actually disconnect the battery. So let me check who is here. Okay, Herat.
Yes, sir.
Okay, Herat, can you explain me why we need, like, can you answer me why we have to actually disconnect the battery first before starting and before doing anything inside the engine bay?
Because current problem, sometime current leak, current shock come like that. I don't know, sir.
Okay, so that's 12 volts. There's a very small possibility that we will get electrocuted by that.
What,
Yes.
sir?
No, with electric, so the current is, so you said electrocution. The answer you were giving is electrocution. Electrocution is not the answer. Thank you. That's not the answer. The answer is actually there's a, okay, so I'm guessing you might actually have, you might remember how the starter motor works, right? So in the starter motor, if it is actually, if somehow we connected a positive with a negative or something, there's a possibility we can actually crank the engine by mistake by a tool. All the tools are actually used. The tools are actually metal. So there's positive and negative terminals coming into the starter motor. For some reason, if we drop a tool, a small tool, if we drop to the correct location by mistake, that could actually end up cranking the engine, right? We could have ended up cranking the engine. To avoid that, before we work in the engine bay, at all times we should actually disconnect the battery. That's the correct practice, but most of the time most people are not actually doing that. Okay, so next part is actually gathering clear enough space. So in order to work or in order to remove the engine, you actually have to uh, get enough space inside the engine. So you need to put your tools and you need to lift the engine out. So you need to get the you need to actually, yeah, you need to actually get enough space inside the engine. That includes, so how you're going to remove the engine. So as shown in the image, those two gentlemen are actually removing the hood. They are actually removing the hood from the vehicle, so they have enough access for them to put the engine train inside, right? Engine hoist inside. So that sort of things also you have to consider. If there's any trim planners like plastic covers and everything, if there's anything on the engine bay, if there's anything covering like engine mounts or something, you actually have to remove all of these components. If you have airbox or all these components, you remove everything to get a very clear view of the engine and all the components in the engine, how everything is assembled, right? That's why it is your next task. Okay, now we move into this. Step 4 is actually using a fender cover. This is something most people don't do. Most workshops even don't do this unless they are like a very professional workshop or very accredited workshops in Sri Lanka. They use it, but others they don't care. But whenever you are working, especially in a car, especially in cars and cabs and some things with the hood, you always have to cover the fenders. Fender means, you know, I'm guessing you know what is fender. So you have to cover the fenders to avoid further or any avoid any damages while you are actually working in the vehicle, right? It could actually end up your oil and your grease may, whatever you have in your hands or your trousers or whatever you were wearing, could actually end up on the fender. So to avoid that, you always have to cover these things, right? That's why it's actually always recommended to cover it. But in the year also, you have to cover everything to avoid any further damages, right? So next part is actually removing the fuel lines, right? So if it is like a carbureted fuel system, it's not a big deal. So carbureted fuel lines are not actually high pressure fuel lines. You can just dismantling the fuel line will not actually end up spilling fuel everywhere because they are not pressurized, right? If you keep the vehicle switch after switching off the vehicle, it will actually the fuel will actually start to go back, so they won't create any issues there. But if it is like a electronic fuel injection systems have a small issue because their fuel system is pressurized, right? As long as you start crank the engine, the system start to pressurize. Okay, so unless you have not start the vehicle for some time, the vehicle or the fuel system still have the pressure. So in such case, you need to actually depressurize the fuel system. So if it is like a vehicle made like 1980s or in 1990s, early 1990s, fuel lines are not having dedicated disconnectors or anything, any special disconnectors or anything. In such case, you can actually remove it very easily using common hand tools. But in such case, where vehicle is manufactured after like 2000, where manufacturers started to use the standard fuel line system, where you have special disconnectors that you can disconnect, and quick disconnectors. Actually, these are known as quick disconnectors, which does not contain any screw joints or anything. They are like just press and remove sort of disconnectors. So in such cases, you need to actually use the tool set shown here, right? Tool set shown here has to be used. This was not included in our list last week, so you can actually add this also. So anyway, if it is a electronic fuel injection system, then in order to actually depressurize the system, what you should do is you have to open the fuel uh, fuse box and find what is the fuse goes up to the engine, up to the fuel pump. So it's electric fuel pump. So you take the electric fuel pump and remove the socket from there, right? Remove the fuse from there. After removing the fuse, you can actually start the engine and let the engine run until the engine stops. Then after engine stop, that means the engine will automatically stop because the fuel is not actually leaving into the engine. So once the engine stop, you can actually use this particular range or quick disconnect ranges, and disconnect the fuel system, right? So once you disconnect the fuel system, you don't have to worry about fuel. But again, in here you have to actually note what type of fuel system is there. So whether it's a return type or non-return type. If it is non-return type, no worries. If it is non-return type, you don't have to worry about anything, because you only have to disconnect one hose or one pipe. But if it is a return type, then minimum you actually have two lines you actually have to disconnect. So you have to actually check what type of a fuel system is this. You can actually very easily understand this once you see the fuel rail. You can actually see if it is only one line is coming inside, that means you only have to disconnect one line. And you can make sure, you can confirm this by looking at the fuel tank. From underneath you can see the fuel tank. How you have to see how many lines are coming to the engine bay. If there's two lines come to the engine bay, that means one is delivering high pressure, other one is actually return fuel line, which is low pressure line. So in such case, you have to disconnect both lines. But if only one line is coming up there, you just have to disconnect one line. But again, you have to notice this. In some vehicles, they have this, especially in petrol vehicles, they have something called charcoal canister. Modern vehicles have their charcoal canister near to the fuel tank, right? So if there's two lines coming, again, you have to actually make sure where these lines are going. Don't misfind the lines or somewhere this is going other way or something like that. So make sure that how many lines are coming to the engine. Okay, so that's step 4. Next is step 5, which is, so most people may feel like this is unnecessary, but I always recommend you do this. especially when you are doing it for the first time, or if you are not comfortable with the particular engine. Tag and label all the hoses and wiring. This is very important. You should do it all the time, right? This is very important thing, because nowadays vehicles, especially nowadays vehicles, even though we only see the engine is not the only component there. There's so many other components that actually assisting the engine. One of such thing is emission controlling. There's emission controlling, vacuum lines. So all these things you have to make sure that you are going to fit them or fix them back the way they came out of, right? So to do that, best thing you can do is tag them. So for example, as I told you earlier, for petrol engine, they have something called a charcoal canister, which is actually used for controlling the emission or evaporative emission. So older vehicles used to have it inside the engine bay, but nowadays, since engine bays are getting very small, this particular component is fixed underneath the vehicle near to the fuel tank, right? So there are hoses going from the engine up to there. So you may not feel like these are necessary, but if you do not fix them back the way they actually came, way they used to be, there could be vacuum leaks, or there could be foreign objects coming through these hoses, or there could be some systems that may not be working properly. For example, EGR system may not be working properly. Then the engine may start to run very bad. For example, engine idle may become very high. For example, for very good example, if you forgo, or if you did not correctly fix back the vacuum lines in electronic fuel injection engines, there's a high chance that you will actually end up having a higher idle because you are getting too much air into the engine. And another thing is, engine may run poorly. Engine may run poorly because EGR system is fixed wrong. Exhaust gas is also coming into the engine, or PCM will start flashing the check engine light, right? PCM may the check engine light, engine may run poorly, engine may not working properly. So that could actually happen. To avoid these things, you always have to make sure that you know where everything came from. So the other thing is, even though we are discussing this is like a very simple thing, so different manufacturers have different method of doing such things, right? Different manufacturers are doing different way. So let me give you a very simple example. You know that gearboxes. So there are gearboxes used by different manufacturers. So we discussed about, when we talk about gearboxes, you might have heard these names sometimes. We have usual auto gearbox, right? Usual automatic gearboxes, and we have something called CVT automatics, right? Then we have dual clutch transmission or automated manual gearboxes, right? Then automatic manual gearboxes are manufactured by different companies. For example, Honda is, oh no, we'll take like this. So automatic gearboxes and CVTs and uh, dual clutch gearboxes. In addition to that, we have manual gearbox, right? So if we take these three automatic type gearboxes, so that means auto, normal auto, torque converter type automatic gearboxes, and dual clutch transmission, and CVT, so constant variable transmission, continuously variable transmission, sorry, continuous variable transmission, and dual clutch transmission, and torque converter type automatic gearboxes. So these are three gearboxes are delivering the same type of same output, but different companies are using them in different ways. So Toyota, if you take Toyota, they not almost they do not actually use anything other than using a conventional gearbox. But if you go to the Honda, they usually use they usually use or they are highly invested on dual clutch transmission. But if you go to Nissan, right, they highly invested in CVT transmission, but they also use dual clutch transmission, right? So but their dual clutch transmission is actually different from Honda transmission. Right? Auto gearbox, the system the auto gearbox works, the basic principle is same. The transmission or the changing system and everything is different from each manufacturer. For same way, for engine also, even though they are doing the same, they are performing the same way, or the output is the same way, their performance or their how they work is may be actually different. So because of that, if you are not familiar with that particular engine or familiar with the particular manufacturer, so best thing is to always mark everything before you dismantle. You don't actually necessarily, it's not necessary to tag them. You can even take photos, or you can note somewhere else, take a video. Anything is okay. Just make sure that you can fix them back. Right. Next part is actually drain all the fluids. So there are few fluids when it comes to engine. First one is engine oil, next one is coolant. In addition to that, most vehicles have power steering oil, or sometimes it's electric power steering. In such case, you don't have any oil or anything to remove, so no worries. So if it is engine oil, you know what to do. Park it in a level ground and remove the drain plug, and after removing the drain plug, open the uh, filler cap. So once you do that, the oil will start to drain faster. So when you are doing that, make sure you inspect the engine oil and oil drain plug. So you can see there's a picture of a oil drain plug, and you can see there's like metal components, small metal is actually attached to that, attached to a magnet. So the thing is, most of the modern vehicles, most of the new vehicles actually have this, and can even install in all the vehicles. They have something called a magnetic drain plug, also known as a magnet. It's very simple thing. It's actually has a magnet at the end of the drain plug. So what it does is, if there's any metal components or any metal sheaves or any wearing components, it will come and collect here on the nut itself. Right, the magnet will actually collect everything. So you can actually, without any trouble, you can actually clean it. But before you do, you actually have to find out why this metal is coming. There's no way, it should not actually fill with metal. If there's metal, there's something wrong. If this is actually having, or if the nut is oil drain plug is actually having metal, check the oil also, engine oil also. If you can actually see like small silver color particles, or if you can see like a glitter effect in the engine oil, that means your engine is actually wearing out. So engine is actually wearing out, also known as metal to metal surface rubbing is there. So that's why it's actually having that color. So if it is there, there's some, if that color is there, definitely you have to see inside the engine there's something going very wrong. So unless you do it now, so once you saw it, if you are not going to do something, that's mean there's a possibility of engine seize up or something to be broken off. So before do that, best thing is to actually do dismantle the engine and see. Okay, so in the coolant also you can do the same thing. Locate the drain plug in the cooling system. Usually this is located below or the lower tank, or the one anywhere near to the ground of the radiator, and open it. Then after opening it, you can also open the coolant pressure cap. Once you do so, the oil coolant will actually start to flow out. In order to remove the power steering oil, there's no pressure drain plug. You just have to locate the high pressure line and high pressure pump line. Then slowly disconnect it from the steering rack side, not from the pump side. Always have to disconnect from the steering rack side. Once you do that, spill the oil. Then you can remove the oil also. Then make sure and uh, make sure that you will be actually disposing everything environmental friendly way. There's an easy. So environment friendly way, don't throw anything into the rivers or any other places. You actually have to recycle all of these things back. So next one is actually disconnecting all the lines and hoses. After you do this, you can actually disconnect all the lines and hoses that's coming in and going out from the engine. Okay, so next part is evacuation the AC system. So it's not that difficult. You can depressurize this what you call this equipment, air condition manifold pressure dial, right? So you can use it to see the pressure, and using a vacuum pump you can completely depressurize the system and evacuate the AC system. After doing so, uh, you can actually start dismantling the air conditioning lines, but that's not the correct way of doing that. Before evacuating using a vacuum pump, the correct way is to use a air conditioned refrigerant collecting machine or a recycling machine, so which is actually expensive. I haven't seen any place using this in Sri Lanka, but I don't know, sometimes some place might be using it. But the correct way is to use this machine to absorb all the uh, mm, refrigerant. R134A is what actually used by most of the cars. I think I may not. I may be off in this. I have checked that. I can't exactly sure it. If I am according to my yes, that's R134A. So then you can actually release the system. There's another thing most people are doing. You just disconnect the line and let the uh, let the AC gas or refrigerant to come out. That is highly dangerous. That gas is a little bit toxic. You should not actually absorb that much high pressurized gas to yourself. So best thing is to not to do that. Use some proper method. Yeah. After, so before you go into the next question, how do you actually identify if the lines belong to the air conditioning system? Subhadapala, you know how to identify the uh, air conditioning hoses or air conditioning line? 92 Sugadapala.
Yes, sir. Yeah.
How do you identify the air conditioning line?
Hello.
Yeah.
I know. I don't know the any idea.
Okay. So right. Thank you. Easiest way to identify the air conditioning line is you just wrap it and or you just touch it. So it actually have like a um, since so you just find out the compressor. From compressor you can actually find there are two lines going. One is going from the evaporator to the compressor, and the other one is coming from the evaporator up to the condenser, right? So these are very thick lines with the uh, cushion or something like a cushion outside. So that's the radiator hoses. These are usually made of aluminium, right? These are made of aluminium, so very easy to identify. It's a thick hose with a thick rubber cover and an aluminium hose going in the middle, right? Not aluminium hose, actually, aluminium pipe. Those are hard lines. These are not rubber lines. These are hard lines, but there's a rubber sort of a rubber cover outside of it to avoid heat actually going into the or to avoid the heat absorption to the refrigerant, the cool refrigerant going in there. So finally, you can actually remove the radiator condenser cooling fan assembly from the vehicle. Okay, so next part is actually removing the exhaust system component. So So you can see like 3 photos here. So exhaust system, basically it's not actually a complete single pipe that welded together. So it's actually comes in several sections. So by looking at it from the bottom of the vehicle, you can actually find, you can actually see the joints, where the joints. So you have to locate the joints and start dismantling from there. So you can see the photo or picture here. Just give me 1 second. Sorry. So this is one joint. This is the joint you actually have to consider about. So when you are dismantling or when you are freeing the exhaust system from the engine, you have to find the first or the closest joint to the engine from the manifold. So you start from the manifold, then you trace back the line, then find the closest joint to the engine. So this is the closest joint. So you can see this is actually a transverse engine. So engine is mounted transverse and the exhaust is actually going underneath the engine, right? Underneath the oil pan. So there's a joint here, which actually have been noted with a small arrow. So one, if you remove these two bolts, the engine will be actually free from the exhaust system. So without any trouble, you can actually lift the engine afterwards. So for any vehicle, this system is available in the same way. So and the bottom image is actually showing it's divided into components. So there's like a few components here. For example, there will be two resonator. In between there's two resonator. There will be some, most of the time there's a connection, but after the first sub resonator, in between the first sub resonator and the engine, there's definitely one joint is there. So you can actually dismantle from there and remove the engine without any trouble. But only issue with this exhaust system is these actually tend to uh, rust, because they are working with a higher temperature inside them, so they started to rust very easily. So for tackling such an issue, you should always use rust penetration oil. Okay, 1 second, or just give me 1 second.
Sir, excuse me.
Yes, go ahead.
Most of the people automatically leave from the lecture and
Yeah,
they.
I saw a message, that's why I'm trying to fix that.
Okay, okay, sir. Okay.
Thing is, I'm not getting, if someone is coming inside or if someone is outside in the, what do you call this, waiting room, I should be able to see them. I'm getting a update, but now I'm not getting anything. Just let me check again. Okay, so I have the, okay, I have closed the waiting room. So if someone is outside, someone goes in the waiting room, now I think they can log back in. They should be able to directly come in there and join. Okay, so where was I? Yes. So the exhaust pipes are usually rusted. So to tackle this issue, usually we use something like a rust penetration fluid. So rust penetration fluid is somewhat similar to this WD-40 you might have heard. But there are, so WD-40 is not for rust issues, it's actually for seized up nuts and bolts, but it is working up to a certain extent for rust also. But in manufacturers like this WD-40, they manufacture a specific rust penetration fluid to tackle such bolts like these, right? So you can use something like that and spray it and leave it for a few minutes, then try dismantling it. Most of the time they come out. If it is not coming out, then you have to cut it and take it out and rethread it, then fix it back. That's the only solution afterwards. Okay, so
Sir,
yes,
rust penetration mean?
sorry,
Rust penetration mean?
rust penetration means okay, so once you put a bolt into a nut, right? Assume you put it into water or something, then rust will be building in. So once the rust actually builds, so uh, thread. So if you consider that threaded nut, so inside threads and the bolt thread, these both will be actually connecting or welded or join into as a one components by rusting, right? So by rusting. So what rust penetration fluid means is just a spray can, something like a spray can. You spray it to the nut or bolt itself, similar to what you do in the WD-40, or something like a your usual like a scent bottle, like a perfume bottle, right? You just spray it into that particular area. For example, yes, let me go. So if this is the bolt, so you spray it around here, right around this area, and leave it for some time. So what this particular chemical does is it penetrate or it goes through this thread, and it's actually dissolve or it's actually break the um, thread, break the rust, break the rust between these two surfaces, and make it easier for us to uh, turn the bolt without breaking the bolt from the body, right? Bolt head from the body. So that's what actually a penetration oil does. It's actually goes through these rusted areas and it actually break the bond between two surfaces. That's the easiest way I can actually explain it to you. But if it is not that much clear, you can always try it in YouTube. You should be able to find some uh, videos showing that how rust penetration fluids are actually working.
Okay, sir, I understand. But,
Okay.
so we apply heating.
No need of heating. If you are applying that fluid, you don't have to heat.
Okay, sir, thank you.
So yeah. So after that, once you remove like all these components, next is attach your left chain. So when you are attaching the lift chains, engines actually do have a dedicated, or they actually given a dedicated spots which you can actually see in the first image. Uh, but it's not always the case. Not all the engines are actually providing this. Most engines does provide it, but there are some cases they actually do not have a lifting or dedicated lifting positions available in the engine bay in the engine itself. In such cases, you have to use a additional hardware as shown in the second image. You can see there's like a metal plate and two L-shaped components fixed into the engine block. So these are additional components that have been attached to the engine. So in order it can be actually lifted. So since this is a V-shaped engine, there's no other place to put the bolts. That's why they have to use something like this. But if it is like an inline shaped engine, you can actually, if there's any hard points that will not break, for example, something like a exhaust manifold, intake manifold bolts, you can actually use to lift the engine if you properly put the chain without damaging anything. Once you put the chain and everything, you actually have to let the chain to get the slack, or you just have to let the chain to uh, feel the weight of the engine. So you apply the weight and you remove the slack. After that, you actually have to locate the engine mounts. So now we come back to the engine mount or the engine layout thing. So you have to find out where the hell is the engine mount. So it's not a exact thing where the engine mount is. There's no rule or something say that there will be engine mount on the middle of the. There's no rule like this, right? Engine mounts will be usually when engines are designed, they're trying to put the engine mounts as much as possibly near to the places we call it as engine vibration nodes. So there are places actually there are places that generate higher vibration or come collect vibration. So if it is possible to put the mounts near to such places, then more vibrations can be actually absorbed by the engine mount. So when designing the engines, manufacturers I try to put it as much as close to these points, but unfortunately it is not 100% practical. So in such cases, they have to move the engine mounts, but it doesn't mean that they are very far away, but there will be somewhere near to them. But it does not, again, it does not mean that engine it will be in the middle of the engine. So it could be front of the engine, it could be back of the engine, it could be even in the top of the engine. Sometimes some manufacturers, some manufacturers, for example, like Alfa Romeo, which is Italian manufacturer, they have used mounting the engine from the top of the engine as well. That means actually from the engine head. Usually we have the engine mounts from the block. In such case, some cases coming from the engine head as well. So you have to actually find out where the engine mounts. So then after finding, you actually have to release the load on them. That means release the bolt, and but still release the bolt, but you should not actually remove the bolt. First you release the bolt and let the bolt or release the load on the bolt and let it sit there. So next, before you do this, you need to actually find out where the engine mounts. So based on the engine drivetrain, there are few layouts of engine mount. So any components that coming into contact with the engine and with the body, right? All the components, like all the drivetrain components, for example, even the suspension and everything is mounted to the body or the chassis through rubber joints, right? These actually absorb the vibrations and harshness, or we call it as harshness reduction. Uh, to do that, these mounts are there. So there's no, even though there's not like a particularly location for this thing to be, because of the weight and everything, there's like a few standard practices used by most manufacturers to put them. So that's what we're going to discuss here. So as shown in this image, there's like two uh, widely used ways of mounting the engine into the vehicle. So if it is like a front engine rear wheel drive or transverse mounted engine and a gearbox. So in such cases, you usually have, right, or most of the time, like 90% of the time, you have three mounts. Two mounts coming from the engine block of the either side of the engine block, and one mount is coming from one mount is actually to the gearbox. So these gearbox mounts are usually from the bottom of the gearbox. At the last end of the gearbox, usually we call it as the extension housing. When we're discussing about the gearbox, we will discuss about that extension housing, but usually it's back of the gearbox. Uh, this mount is actually joined. So it's also joined from the bottom of the gearbox. It's not coming from the top of the gearbox. It's always coming from the bottom of the gearbox for easy dismantling and assembly. If it is a transverse arrangement, that means front engine type of arrangement. So front engine, front wheel drives type of arrangement. The gearbox mount is usually coming from the top of the gearbox. Usually it's coming from the top of the gearbox because in these type of engine or vehicles, usually the engine frame rails, frame rails are actually going over the gearbox, so they have to have the mount from the top. So in addition to that, there could be additional 3 mounts, right? Additional 3 mounts could be there. So those 3 mounts could be either from both sides of the engine and front of the engine as shown here. So that means front of the engine means, I think you can remember this, front is always, we start front from the, so how do you actually say, identify which side is the front? So back is where the engine, gearbox is assembling. So that means flywheel side is always back side. So this is the front of the gearbox, front of the engine. So there's one mount here, and in addition to that, there could be 2 mounts of the either side of the engine block, right? But the usual practice is only to use 3 mounts. 3 mounts is the bare minimum needed for any engine to be mounted. So because of that, most manufacturers, so 90% of the chances, again, 90% of the 90% of the chance, 90% of the yeah, 90% of the chance is there. Most of the time there will be 3 engine mounts will be there. Out of that 3 engine mounts, the transverse engine mounting usual pattern is 1 on the front of the engine, 1 on the top of the gearbox, and 1 in the firewall, in between the firewall and the engine, right? So that means this one. This is the one between the firewall and the engine. So the firewall goes like this, and the engine comes here. So there will be 1 between these 2. That's it. Most engines do not actually need this. They are not actually using it because adding another engine mount will actually add cost. So if it is not necessary, it's not there unless it's like a high power vehicle or something. There's like more chance it will not be there. Okay, so that's how you usually find out where the engine mounts are there. If it's a transverse mount, there's always minimum there's 3 mounts are there. So 1 always goes to the gearbox, and there will be additionally minimum of 2 for engine. So if it is a transverse engine, it's from front of the engine and either side of 1 from either side of the engine. If it is a inline mounted engine, there will be 2 from either sides of the engine. Okay, that's how usually engine mounts are there. But as you can actually see, they are not always in the middle. They are usually either near to the front or near to the back. But if it is but by looking at the whole package or whole assembly, you can see where the center of gravity and where the weight is actually coming from. Based on that, these things may actually change. Okay, so that's how we consider or find out where the engine mounts are going. Okay, so step 10 is now you have the lift and you have fixed, remove everything, you know where the engine mounts are. Now your task is to slowly take them out, right? So how do you do that? Slowly lift the engine using the jack stand, sorry, jack, slowly use it, or slowly hoist it. While you are hoisting it, you can actually turn your engine lever and tilt it the way it should be, and bring it outside. But before you do everything, before do anything like this, you have to step by step take them, take the engine out. You always have to inspect if there's anything in, if there's anything still connected to engine. If there are anything, you just have to remove it and go on from start uh, going forward from there onwards. So that's what actually shown here. So as you can see on the bottom picture, it's actually a 6-cylinder engine. They're trying to take it out, use as 7 MGT. That's the engine code. It's actually, you can't actually see that, but anyway, so you can see one hand is actually holding the engine, so he's trying to tilt the engine as much as possible to bring it out. So it's taking out from the top is not the easiest way to take the engine. That's why I actually wanted to show the image. If it's like a small engine, very easily you can take it, but if it's like a big engine, like something like this, it's not easy thing to take out. So in such cases, figuring out how to take the engine out. So taking out the engine, there's like two ways to take an engine out. There are two main ways to take an engine out, or there's two ways you usually use to take the engine out. One is taking the engine out from the top. So that means we will be using a engine hoist, right? That's what we actually discussed. Remove the drive shafts or prop shafts. You can't see the slide. Can you? What do you mean by you can't see the slide? Okay. So figuring out how to take the engine out. So there are two ways, two usual ways that we use. One is top, other one is taken out from the bottom. So by doing it for some time, you may be able to identify, oh, for this particular model, it's always easy to take it out. For some particular models, it's always easy to take it from the top. If it is a small engine, if it is like a small, very small engine, if it is not cramped inside, then it's always easy to take it from the top, if only you need the engine and gearbox, right? But if you still need the drive shaft, suspension and everything, it's always beneficial to take it out from the bottom of the vehicle, because everything you can take it out as a whole section, right? Okay, or a whole assembly. So taking out from the top, you just have to disassemble like drive shaft and all the other components, and slowly take it out from the top. But if you are taking out from the bottom, what you should be doing is you have to remove the support. First, you have to support the engine and gearbox from the bottom. Then remove the wiring and all the other accessories and any other components, wires, everything. Remove everything, right? Uh, you can still keep the drive shaft if you want. You can still keep the drive shaft, and but if you are keeping the drive shaft, again you have to actually remove the or disassemble the suspension or suspension mount, right? I will explain that again. So next, actually remove the bolts holding the engine cradle, so and lower the whole assembly to the bottom as shown in the shown in the bottom pic. So first thing is first, First thing you need to understand what is an engine cradle. Do you know what is engine cradle? Have you seen the engine cradle when you were discussing in the foundation of automobile technology? Have you discussed what is an engine cradle? Someone has to answer.
It's all the engine. When we are getting down, we need to hold the engine. No, it's help to hold the engine.
Yes. So engine cradle is actually keeping the engine. So engine cradle is not only using for holding the engine, but it's also supporting the suspension also. It's also like a subframe. It's more like a subframe, right? I will actually show this. So then you can actually remove the engine from the bottom, right? So in order to understand whether it's to take it from the bottom or top, you have to actually consider by looking at the engine or how are the components assembled, so which way, so how restrictive is to take it out. So after considering all of these things only, you can actually identify whether it's easy to take it from the top or bottom, right? For example, if I give you like a small example, for anything like a Toyota Corolla or something, it's always easy to take it from the top if you are only taking engine and gearbox, right? But still, if you want to replace all the suspension components like the rubber mounts, rubber joints, the engine mounts, and you also need to do the engine rebuild or something, that at that case it's easy to take all the whole components like front suspension assembly and engine as engine gearbox assembly as a whole unit with the engine cradle from the bottle. It actually comes as a subframe, so you can take it everything from the bottom. But if it is like as shown in this is a Porsche 911, so something like a Porsche 911 or like a Volkswagen Bug or a Volkswagen Beetle, in such case there's no doubt taking it bottom is the easiest way, because there's not enough space to take it out from the engine opening on the back, right? Those are the two options you have. But something like a Mini Cooper, right? Not the older version, the new version Mini Cooper. So it's also very cramped inside. So there's no way to you can put any hand or anything to dismantle or disassemble any boards and everything. Even if you can do it, it takes so much time. It's always easy to take the whole component, like whole sub assembly or subframe or engine cradle as a complete unit from the bottom, right? In addition to that, there's another method you can actually use: slide it forward, right? Slide it forward or slide it outward. So this is used by heavy vehicles mostly, but there are some passenger vehicles that actually use also. So as shown in the first picture, so the first picture is actually this is Audi RS4. Audi RS4. This Audi RS4 actually comes with the method to actually bring it outwards from the top of front of the vehicle, because the reason for that is the engine bay is so cramped. You have a big engine in a small engine bay, so in such cases this is easier. So it's actually manufactured to take the engine out in this way. It's actually designed and manufactured to take it out this way. So it's not a common setup or common way for available at the moment. So in order to remove it nowadays, the most common methods are taken out from the top or bottom, but the sliding outward is not a very common method, but used in heavy vehicles. It's available for heavy vehicles mainly because of the heavy components involved in these. So sliding is actually easier than lifting the vehicle. So they are designed to uh, take it out in such way. But there's another reason for that, which I will explain. Sometimes you may be able to guess the answer. So um, here, another such vehicles you can actually slide the engine front without lifting is the US manufactured older US vehicles, such as these Camaros. You might have heard the Camaro or Mustangs. So those have like something called a front clip, also front fenders and the front fascia or the grill and everything is a separate section. You can bolt it and remove it, so engine can be taken out. So in those vehicles also you can do it. They're not a single body, or they are not attached to the other components of the body, right? So those are the usual vehicle. Some vehicles you can actually do it. So but in the modern vehicles, most like 90% of the modern vehicles, you can't actually do it unless you do some damage to the other components. Why unless you cut, or you cut away some components. So why do you think it's not available in modern vehicles? Any answers? Siam, FA Siam 90, GT90. Why in modern vehicles it's not available, or they're not manufactured to slide the engine outwards in such way? Why they are not doing it?
I don't know, sir. I think safety purpose.
What safety? Whose safety?
Sir, I have no idea.
Okay, Niroj. Yes, we remove too many components. Sugatapara, we want to remove many components. Well, you are removing engine, so definitely you have to remove many components. So whatever in front of the engine, you always have to remove it, because otherwise you can't take the engine out. You can't keep the radiator and everything inside and keep you can actually, but there's a possibility you may damage. So since you are actually since you are almost dismantling all the connections between them, there's no point of actually keeping them. So you can remove it. So it's not actually the case. So I told you like heavy vehicles use that because they can do it, and I told you that all the vehicles, all the muscle cars actually have this solution, or they are used to have it like this. The reason is the manufacturing. So manufacturing is actually quite different. So so I'm going to discuss the engine cradle, how it's actually attached and everything. With that, with this, it's actually explainable here as well. So, in a modern vehicle, the assembly or the manufactured of a modern vehicle is something like this. So, it's have something called a monocoque chassis. Monocoque chassis means your usual chassis and body is combined into a one, or integrated into a one whole section, right? So, chassis is actually integrated, or body is actually integrated to the chassis. So there's no chassis rails are going separately. So most of these components are actually what we call this load bearing members, right? Load bearing members. For example, this section is a load bearing. Whole area is load bearing, right? This section is a load bearing cell, something like a cell, right? This is actually called as a safety cell, because if there's any accident or something happen, this front section. Let me change the color. This section, right, act as a crumple zone and absorb all the impact, right? Absorb the impact and let the occupant stay safely inside, right? So these sections still they are load carrying members, but they actually act as a part of the safety set. So as shown here, right? As shown here. So since this does not have a separate beefy chassis in order to support the body weight and all the other forces acting on them. So these are transferring, or load is actually transfer from one member to other using something called triangulating. So these actually load is actually triangulate. So let me try to do something. So if we have a stick like this, right, or a let's say this is a rod, right? This rod is not actually strong, but even if we join another rod, this is also not actually strong. But if we join it as a triangle, now this is become a like a whole unit, and the load is actually transferring from one to another, and each one of the rods are actually supporting the other two, right? So that triangulate the loads and distributed the load among them and allowing them to have a smaller diameter. In this case, in the triangular, the same method is actually used in the manufacturing. These actually have very thin gauge, but because of these integral shapes and this triangulation, this can actually bear even higher loads, right? Even higher loads can be actually bear. So similar to that, right? But in the same way, if you consider this front section, right? This front section, the front section, the suspension mount in for this particular application, this is actually having something called a MacPherson strut suspension system. So that means you have a suspension, one lower arm like this, and coil spring and coil spring assembly or strut assembly goes like this, right? So the load from the load from the road, all the loads from the road will be actually transferring through this suspension assembly. It will be transferred to this top mount, right? So this top mount has to be supported. This is only supported from, it's actually having the support from this particular bar, but it's in triangulation. So this additional triangulation from manufacturing, it's actually provided from this bar. This is actually known as the radiator strip. So it's actually support the radiator as well as these two suspension components. So when you need even more additional support, then in such cases, you have something called these bars. You can see there are two bars here. So these are actually called as strut braces. So they provide even more strength, right? So once you put all of these things, only you get the strength. So since you don't have a separate chassis, this is acting as a chassis. This need triangulation, right? So once you triangulate everything, it's actually act as a like a box sort of thing. So in order to take the, or in order to slide the engine out, you actually have to remove this part, right? So removing can be actually done, right? Removing can be actually done, but removing of this particular section means either you have to redesign the whole chassis, right? Either you have to do the whole platform or whole frame has to be redesigned, or you can just add nuts and bolts to this front section, right? It's not the most or the best answer, but it can be done. So if you add nuts and bolts, it can be done, but adding a nut and bolt will not be enough. So each and every section, so this top, front and bottom section, both has to, all parts has to be assembled with nuts and bolt. Even though it can be done, once it done, so for assume that each side is having two bolts per uh, one connection, so there will be two sections, front and bottom. So 1 2 3 4 four connections, four bolts and four nuts, right? Four bolts and four nuts. So assume that you are making 100, like 200,000 cars, four bolts and four nuts, sorry, eight bolts and eight nuts, sorry, eight bolts and eight nuts. That means 200,000 into 8, 800,000, 800,000 into 800 nuts and 800 bolts you have to purchase, and 800 nuts and 800 bolts you have to fix, weld, assemble. So everything costs time and time. So time means money. Purchasing costs money. So for a manufacturer like this is a huge expense. For them, it's a huge expense, even though it's one single nut and bolt. So in such case, if it is not exactly necessary, they will not do it. There's no point of doing that, even though it's make our repairing or the mechanics works difficult. It's still possible to take it out. So that's why most vehicles do not actually have it. But in some vehicles, they can actually have it without us without any trouble. For example, uh, some vehicles they actually have to have it. So at Audi RS, the vehicle shown here, right? The vehicle shown here is actually vehicle shown here, the top one is actually having 5-cylinder engine. So 5-cylinder engine in a very small package. The engine compartment is very small, so they can't actually take it out from the top. They only can take it out from the bottom. So as a solution, they fixed it, even though with the additional cost. This is only coming for RS model. So RS model is expensive, so they are not actually manufacturing them as the usual model, so they can do it. In the bottom application, they have a chassis. So chassis is actually doing the load bearing part, not the body part. Body panels are not supporting the load bearing. So in that case, they can do it without any trouble. That's why heavy vehicles also can use it, because two reasons they actually have to, because of the weight of the components. So it makes the maintenance easy. And the second thing is they actually have something called a chassis, which actually transfer the load. So they don't have to worry about the triangulating or thickness of the metal or anything like that. So because of that, they can actually do it without any trouble again. So that's why we have it like this. So this component is actually called as a radiator stay. So that's necessary, and taking it out and putting it back is not an option in the most cases. Next one is the engine cradle. So engine cradle is actually fixed. Oh, so engine cradle, you can actually see the engine cradle here. So if you look at this section, you can see there's like a dark black color section attached to the frame rails of the chassis, right? Or the frame rails of the vehicle body. So these frame rails have a like a triangulation component that's bolted, right? These components are bolted into the chassis. So this is actually known as the engine cradle, right? Also known as a subframe. So this is where engine is actually going to rest, right? This is where engine is going to rest. In addition to that, as I told you earlier, this lower suspension mounts will be actually mounted here, and upper suspension mount, or in like MacPherson strut type suspension system. MacPherson strut type suspension system, the suspension or the coil spring, strut assembly will go and mount onto the top of this frame rail, top of the frame, right? So if you dismantle the subframe from the underneath, you will be actually releasing the engine, gearbox, as well as the lower suspension mounts, right? Lower suspension mounts, because lower suspension mounts is actually mounted to the this engine cradle, right? So once you dismantle those things, you have actually removed all the connection to the chassis except for the top mount. So once you remove the top mounts, right? Once you remove the top mounts means this suspension top mounts, that means shock mounts or the coil spring assembly mounts. Once you remove everything, the whole unit can be dropped from the bottom, right? So once you do this, you have something like this. So the upper image is actually showing upper image is actually showing a whole engine cradle component, right? This is completely an engine cradle, and the bottom is actually from a Mazda Miata MX-5. This is quite somewhat different from other vehicles. The main difference is you can see there's this component, right? These components is have been attached there because it's actually a sports car, so it provides the additional rigidity to the chassis. That's why it's actually attached there. But you can actually see this. So this is actually MacPherson Struct front suspension. So if you look at here, right? So these are the top mount of the strut assembly, and the lower assembly is actually mounted to the frame underneath here. There's a dark color frame going underneath, so it's mounted there. So this whole assembly, right? If you remove, if if you could have cleared, right? If you could have cleared, or if you could have removed this propeller shaft from here, from the behind the gearbox, and if you remove this frame section, then the whole front uh, suspension and the gearbox and engine mount could have taken out. Similarly, for this particular vehicle, we also have something called a subframe, which houses or which hold, sorry, which hold the differential and all the suspension components. So they could have actually, so they have removed everything. So this actually shows how everything is actually underneath. So in manufacturing, this is actually one advantage of having this this engine cradle is a very good thing for manufacturing. It make the manufacturing process easier because manufacturing process easier because all the components that goes underneath the vehicle can be assembled separately, and everything, the body and all the other components can be assembled separately in um, two different assembly lines, and finally only they have to come together. So that actually saves a lot of time, which in turn saves a lot of money. That's why this system is actually being used. There's no other main reason for using this. Still, you can actually, without this also, there's other ways to manufacture the vehicle. So the main purpose of doing that is making it easier for manufacturing. So there are so few other more videos I have attached here for you to watch regarding this and assembly, and especially about this particular chassis or particular drivetrain. Okay, so next section is actually engine dismantling. So the problem is engine, as you know, is quite complicated components. It's a quite complicated system, and explaining it using this video without the engine, without an engine or dismantling method is not the most efficient way. And I know that most of you have seen and have dismantled the engine, so you have a certain idea how this is done. So idea here is these are, as I told you earlier, this whole module is a hands-on experience module. But since due to this COVID-19 guidelines and everything, the university are closed. So because of that only, we actually doing in this way. So since we are doing it in a like a long distance, of what do you call this? Yeah, long distance learning sort of way. Unfortunately, this section, assembling and disassembling, I can't teach it online, right? And I don't actually have any equipment to teach it at my home, so it's not the best choice. But what I'm planning to do is so because of that, I went to YouTube and found few videos. You can actually go through the videos. I suggest you to go through the videos because I'm planning to discuss about these videos in the next class, and discuss about the construction of each components, why blocks, for example, engine block is manufactured this way, that sort of things, right? Since we are going to discuss about these things next class, I want you guys to go through these 3 videos. So the first one is disassembling and complete disassemble of a Nissan 350Z 340C, 240C, 200C or something engine. So it's an older vehicle like 1970s or something. The construction is quite the same, but the technology is somewhat different. And the second one is a Mini Cooper engine. So it's a BMW engine. So so Japanese engines and BMW or the German or European vehicles have different approach to some components. For example, the belt tensioners or how they use the materials. There's small differences. So you will be able to actually see these things while you are going through these videos, and I particularly expect you will be actually very keen on these things. And finally, there's a stop version video. There's some video YouTube channel actually called How a Car Works. It was a very good video channel, but unfortunately, I think it's not. I don't think they are uploading anymore. So they have something called something like a whole disassembling process as like a stop motion. So you can actually see step by step each component is coming out, how it looks and everything. So what I suggesting is as a guide, go through these videos. We'll discuss in the next class about these components, how the testing and everything. And once you are coming back, when you're coming back, right, when you will be coming back in the next, because now the vaccine, they're going to start the vaccination. So you will be coming back, hopefully you'll be coming back soon. So once you come back, we'll be dividing you into groups again. We'll be doing the assembling in a smaller scale with what we have. We'll be disassembling and assembling an engine. So this will be like a more or less like a guideline for some way of getting prepared for that class or that particular practical. Okay, so that's it for today. I expect you will be looking into, or you will be watching these videos before you come to the next class, because these things will be very important in the next class. So next class we'll be discussing of inspecting disassembled engine, what part, which section, what are the components, that sort of things. And we will I'll give you a small introduction to overhauling of an engine. Usually we don't have any overhauling equipment, but I'll give you a small explanation how overhauling of a vehicle works. I used to work in such a place, so I have quite a bit experience on that, so I can explain it. And yeah, as I told you in the beginning of the class, in the next class, at the end of the next class, we'll be having a small quiz through online. So I hope you'll be, when you're coming to the next class, I hope you will come very much ready with all the this, and you have been, I hope you have already gone through everything I have taught all year. So safety is not a big issue, but everything has equipment and this part and these 3 videos. So go through there and come back on the next class. We'll be discussing certain things on the class. Then we will, then we will, we will join on. We'll see on next class. Yes, a few questions. If you have any questions, you can ask now. So can you upload this lecture slides to LMS? Yes, lecture slides are already uploaded. Okay. Usually I upload the lecture slides before the class. I think I didn't do it today. I will upload as soon as this finished. I will upload that. Yes, video. I can upload the video, but you didn't comment anything on that. So if you want the video on LMS, I can just upload it to LMS. But in the last 2 batches, they expected me to upload the video to YouTube because it's cheaper to watch the video in YouTube, I think. So still I'm uploading it to YouTube. There's no point of uploading to 2 places because that's not economical for me. So I upload it to YouTube and I then share the link in the LMS. But if you want to upload it to LMS, yes, let me know. I will directly upload it to LMS. Okay, it's better to upload to YouTube. Okay, still I think the LMS If you go to the LMS, the links are available. Videos are already in the YouTube, so you can find it through that link. Yeah. Any other questions? How about your LMS problems? Did everyone got the LMS accounts now? So no one answering means I think everyone is having LMS. So I don't think we will be having any problems in the quiz. So if you do not have an LMS,
Sir?
yes.
I think they didn't get access LMS. Someone have that problem.
Around how many is having this issue? Madhushan, do you know how many is having this issue? Okay, someone have problem in LMS. Okay. Oh, Lakruan, yes, you have a question? 9 people. Okay, 9. Lakruan, raise your hand. I don't have it. Do you have Office 365 access? Do you have the Office 365 access?
Yes, sir. Email, no?
Yeah, team access you all have, right?
Yes, sir.
Okay. So I will look into this. Before we conduct the quiz, I will look into which way is possible. And based on that, I will conduct the quiz. So in both platforms, you can actually conduct the quiz without any trouble. So I don't think it will be a problem. So we can conduct the quiz. If not, I will come up with some other solution. So no worries about the quiz. Just get ready for the quiz, right? Just get ready for the quiz. It's not a big, difficult quiz. It's a small quiz. So you just have to answer a few questions. That's it. Okay. That's it. Thank you for coming. If you don't have any question, do you have any questions other than that? Some not difficult things, actually very simple things. I'm just going through like small procedures. These are the things you have to do. That's all, like a small discussion classes. You can actually call it as discussion classes. And please watch the videos. I didn't want to upload the videos here. It's too long, like some around 1 hour, other one is around half an hour. So I hope you will be able to spend that much of time and go through the videos. So yeah. If there are no other questions, I will stop the class from here. Yeah, thank you for coming. Good night, everyone.
Thank you.
Thank you, sir.